Today we are at our final lesson, kind of working through some sequences and series problem solving and like introductory lessons for how we can use the formulas and then also just kind of like problem solve more intuitively to figure out different problems involving sequences and series of questions. So we're going to start with this warm-up today, which is kind of like our sequences problem solving type questions, and we're going to see what we can find from this. I also have a little document which I will post up for you guys, but this is essentially just kind of like a summary of sequences and series, and it has your formulas and what each thing means, and then kind of like a definition and example of each. So hopefully that will be helpful to you guys, but these are kind of the main formulas that we're looking at for our lesson today. We're going to be utilizing all of them simply because series is the sum of a sequence. So sometimes we'll need the sequence formulas to get a piece of information to help us with the series questions. So I'm going to be utilizing all of these formulas today. So let's start with our arithmetic sequence warm-up. So we know term 3 is 25, and we know term 9 is 43. There's some kind of constant addition happening here to get us from 25 to 43, and we want to know how many terms have a value that is less than 100. Okay, what do I need to know in order to figure that out? We need to know what that difference value is, so what is our constant addition that's happening? And yeah, it would be great if we know where this starts, where the sequence starts. So it would be great if we know A. Right now, we know that term 3 is 25, and we know term 9 is 43. Once I figure out D and A, then we'll figure out the 100 part of this. But first, I need to figure out what this sequence is going up by and how it's changing, right? And where it starts. So we did an example like this 2 days ago, where we tried to figure out using the arithmetic formula for a sequence. We tried to figure out A and D by setting up two equations with two unknowns and then using elimination. So I'm going to set up a first equation using the information from term 3. So that would be term 3 equals A plus, and then because this n is plugged in as 3, this one will be plugged in as 3. And then I'm going to do the same thing for equation number 2 with term 9. So plugging in 9 for my n's. And then I'm going to actually just plug in the term values here. So I know the value of term 3 is 25. And I can simplify that 3 minus 1 just to 2. And I know term 9 is 43. And again, just simplifying that 9 minus 1. Okay, so very similar to what we did a few days ago, we're going to stack these guys on top of one another, and we're going to use elimination to get rid of those A values. And we're going to see if we can find A and D. So I'm going to subtract. Sometimes when we're using elimination, ladies, you got to stop, okay? Unless there's a problem. Is there something wrong? Okay. Sometimes when we're doing elimination, we can add. We have to use our common sense. If I want to eliminate the A's and they're both positive 1A, I should subtract them. If one was negative and one happened to be positive, which usually doesn't happen in this scenario, then we add. So just use your common sense here. So here I'm going to get, what, 18? And then 6. And we'll divide out the 6 to get a D value of 3. Okay, and then I'm subbing this back in to get my A value. Which gives me an A value of 19. Okay. This gives me information about my sequence, but it doesn't answer the question. This is more of like a problem-solving type question, right? It's not just find A and D. Now we want to answer the question, how many terms are less than 100? So some number of terms, term n, might have a value of 100, or maybe depending on how many multiples of 3 from 19 we can go, maybe some term has the value like 98, 99, or like 101 depending, but we're going to set some term Tn equal to 100 and see how many terms. Maybe it will be equal to that many terms, maybe it will be like a little bit of a decimal, and then we'll kind of unpack that once we do that. So now that I know A and D, I want to know if there's a term that has a value around 100. So this is my general equation. And I'm actually going to plug in the value 100 over here, just so we can check out what's going on and see if maybe a particular term number is equal to 100, or maybe it's like slightly over or slightly under 100. Hopefully it will give us a whole number. That would be nice. Okay, so just isolating here, I'll divide out the 3 as well. Okay, I believe this gives us 27. And then when we move over the 1, we get 28. Okay, so the 28th term has a value of 100. What is the question asking me again? Natalie?
How many terms are less than 100?
So if term 28 is equal to 100, how many terms are? Yeah, so 27 terms are less than 100. Okay, so that part of it, you just need to use your common sense, right? If I find that the 28th term is 100, then of course I don't want to include that in my number of terms. Then 27 will be under 100. Okay, so we're going to use this kind of like elimination process again today, which is why I just wanted to remind you about it in our warm-up for today. So we did talk about a little like quick way that we can find the D value when we're given 2 random terms, and that is that we can actually find D pretty quickly by doing the difference in the term values over the difference in the term numbers. So we just do this, and then what this ends up giving us is 18 over 6, like what we had over here. So that's a really quick way that we could have found a D value of 3. So rather than like doing this whole elimination thing, but there will be a case that you'll see today where you have to use elimination, which is why I just wanted to kind of get you guys started with the elimination process. So yes, there are other ways to solve it, but in some cases we might have to use elimination. So just want to make sure we all know how to do that. Any questions on this one before we start some of the series questions today? We're all good? All right. So we're going to go over some problem-solving questions with series. We introduced the formulas yesterday, so we know our SN formulas now. And then we're going to look at arithmetic and geometric series problem-solving, basically. Okay, so first one. In an amphitheater, seats are arranged in 50 semicircular rows facing a domed stage. The first row contains 23 seats, and each row contains 4 more seats than the previous row. How many seats are in the amphitheater? Okay, so this is kind of what we have. If this is like our stage, we have rows that are set up all around here. And of course, as we move out here, the radius of that kind of semicircle grows. So of course, the number of chairs in the row must also grow accordingly. So in the first row, we have 23 seats. What's in the next row? Okay, and the next row after that? And so on, right? Okay, so we kind of have an idea of what the numbers of seats in the rows are going up by, and what that sequence looks like. Now we want to find how many total seats are in the amphitheater. So not only do I want to know kind of like how many seats are in each row, but I actually want to sum all of those seats together if I want to know the total number of seats. So our A value here is 23. That's the number in the first row. Is this arithmetic or geometric? Yeah, so what's our D value?
4.
Awesome. I want to know the sum of the 50 rows, the sum of the chairs in the 50 rows, right? And that means my n is 50. Okay? I'm going to use the arithmetic sequence formula, or sorry, series formula, that involves A and D. So the only way that I can use the secondary one that I showed you guys, this one here, is if I know the amount of seats in the 50th row. Do we know the amount of chairs in the 50th row? So we can't use that one. Could I find that using the sequence formula? Absolutely. So I could apply the sequence formula first, find T50, and then use that second formula for Sn. But I think we can just do one single calculation here by plugging in our info. So we'll do S50. And anywhere I see an n in this formula, I'm plugging in 50. And then we're just going to calculate. If you're someone that isn't super comfortable getting correct answers on your calculator, my suggestion would be that you just take a couple steps and simplify this first before you start entering it all into your calculator. Okay? So I might just do this and kind of take it piece by piece here so that I don't make any mistakes. Okay? And no harm in just taking it kind of step by step and making sure that we are doing it correctly rather than just in case we enter it all into our calculator and make a mistake. Better to go slower if needed. Okay? So, how many rows in the amphitheater? Or how many seats? Did everyone else get that? 6,050? No?
I started plugging all of it into my calculator.
Yeah, see, so you're someone that might have to do this, right? All right, 6,050. Any questions on this one? We're all okay? All right. So notice that this didn't tell you anything about arithmetic and geometric, right? You have to kind of figure that out yourself by seeing what's happening. Is everyone okay if I flip here? We're all good? Okay. All right, so let's try another one. Determine the sum of the series where we have negative 31, negative 35, negative 39, and so on, all the way up to the term value, negative 403. Okay. So the reason, I mean, we could have commas in between here, but the reason why we don't have the commas is because these are just being subtracted all from one another, so it's showing it as the series itself. So we don't necessarily need that. What do we know right now, off the bat? Kylie's? Yeah, what's A? Okay, and what else do we know? Kendall? Okay, how do you know it's D? And not R? Yeah, so we're subtracting 4 each value that we kind of move forward here. Great. I know some term at the end of my sequence, I don't know what term it is, but I know some term at the end of my sequence has the value negative 403. Okay? We run into a problem here because if I am trying to find the sum of a sequence and I don't know how many terms are in that sequence, how can I find the sum? I can't use the formula. I know, it's a problem, right? Derek? Oh, okay. So Derek is suggesting that we use the other formula so that we can figure out how many terms are in this sequence and then apply the sum formula to that. Okay, so we're going to use our arithmetic sequence formula. And we're going to plug in the value of the very last term that we see there. Ideally, like this is quite a large sequence. Ideally, I do not want to write out this sequence until I get to negative 403, right? I don't want to do that. That would not be fun. So we're just going to plug in here. Our goal is to isolate for n so that we know the number of terms. Please be careful, guys. When you put in a negative in for d in this formula, it can't look like subtract 4. Okay, so you need the brackets around here so that it looks like multiplied by 4. or negative 4, I should say. Okay, so we're going to solve for n. Okay, so just isolating here. Or maybe we'll do this in 2 steps. Okay, so if you're entering this into your calculator, we'll want some brackets around that top part there. Okay, what'd you guys get for n minus 1? Okay, so when we move the 1 over, we have 94 terms in our sequence, or series, or whatever. Same thing. Sequence is the sum of a series. So now I know what I'm trying to find the sum of. I'm trying to find the sum of 94 terms. So now I can actually apply one of these 2 formulas. So I'm focusing in on these guys over here. Which one should I use?
The first one.
Why do you say the first one, Natalie?
Because we see n.
We know the value of the 93rd term, or is it 94? 94th term. It's negative 403. So that will save us a little bit of time. So I'm going to plug into this formula, and when I know the first term of the sequence, when I know the first term of the sequence and the last term, I get to use this formula. Just saves a little bit of plugging in. Sorry, I'm thinking about the last question now. So sum of 94 terms, I'm plugging in 94 for all my n's. The first term was negative 31, and the last term was negative 403. And then we're just going to calculate. So again, if you're a person that maybe needs to calculate more like piece by piece, this will be 47 times negative 31 minus 403, so negative 434. And then you can multiply those together. So what do we get? Anyone? Where's everybody's calculators today?
It's like a big number.
It's a big number, yeah.
Negative 20,358.
Great. 98, right, you said? Okay. Awesome. Ideally, we kind of need the formula for this one because I don't want to write out 94 terms and then add them all together on my calculator, right? That would be a big waste of time. So that's why we have the formulas. I know some of you are kind of saying oh, can we just write out the things and add them? Yes, you can. But in some cases, we want to use this formula to be more efficient. If you're sitting there on a test and you're writing out 94 terms and you're adding them together, you won't finish on time. Right? So we want to make sure we choose the most efficient method. That's just more of a common sense thing too, right? Let's not waste our time. Let's be efficient with what we're doing. Okay, questions? We're good? Okay. All right, next question. Determine the sum of the first 20 terms of the arithmetic series in which the 15th term is 107 and the terms decrease by 3. Okay, I'm going to give you a couple minutes here. Try out some things here. See what you can problem solve with this one.
It's like 10 minutes.
Not 10. I don't think you should need 10. I'll give you a few minutes to get a head start and see what you can figure out with this one, okay? So we'll pause. So I took the liberty of starting the little first part for you guys here. How many people got 149 for A? Okay. So I saw some people that were writing out the sequence. Arguably that could be, because there's only 15 terms, that could be fine. If I have the 15th term and I want to go backwards to get the first term, or forwards, if I'm going forward, I'm subtracting 3. If I'm going backward in the sequence, what am I doing? Adding 3, yeah. So this is a quick way that we can just calculate the first term, and then once we know the first term, what did you guys do? Oh, you didn't get there? Okay, so how should we move forward from Kylie's? Yeah. So I don't know the 20th term, so perhaps maybe we should use this second formula for arithmetic series. And then we're just going to find the sum of the 20 terms. Again, could I write out the terms? Yeah, I probably could. It probably would take me about the same amount of time. Maria, I saw that you were writing them out. Did you finish in that time? You didn't finish? Okay, so probably the same amount of time, right? Because those guys still were finishing the sum as well. Okay, so we'll plug it in. So you guys see how sometimes we need that sequence formula to help us out with finding information to find the sum? What are we waiting for?
I couldn't figure out n was 20, but I got it now.
Okay. Okay, and if you want to take a couple extra steps to calculate here, that's totally fine. Take your time. You don't need to plug it all in at once into your calculator. Okay, this way as well, if I do it maybe in a couple steps, if you happen to calculate something incorrectly, maybe I can give you a couple of part marks, or when you're checking back over your work, you might be able to notice your mistake easier than if you just entered it all into your calculator. So here I'm getting 241 times 10, so that will give me 2,410 for the sum of the 20 terms. Any questions for this one? Okay, I think a good approach is like start by writing down everything you know and then see what you're missing and see how you can kind of figure that out from the sequence or series formula. Okay, any questions before we move to the next one here? Okay, can I flip?
Yes.
We're all good? Okay. All right, 10th term of an arithmetic series is 34, and the sum of the first 20 terms is 710. Determine the value of the 25th term. Okay, don't write too big on this one. Save yourself some space. We know term 10 is 34. Do we know the first term of the sequence? No. Do we know the d value? No. But we do know that the sum of the 20 terms is 710. We also want to know the 25th term. That's what the question is asking. So lots of unknowns here. These scenarios are the scenarios that I talked to you guys about that we absolutely need elimination to solve. So we're going to set up two equations with the information. In order to find the 25th term, we need to get that a and d value. So ideally, I'd like to set up two equations that have both an a and a d value so that we can solve using elimination. Okay? So I'm going to use first the sequence formula because this is a term number and not a sum. So I know that I have to use this sequence formula here. And I'm entering in term 10. I don't know a, but I know that the term is 10, and I don't know d. And then I'm going to sub in the term's value and just simplify 10 minus 1 to 9. Okay? So similar to what we just did in our warm-up question for today. So that's the first thing. The next thing that I want to do is I want to set up a sum formula that has the same variables so that I can use elimination to solve. If I have two equations with the same two unknowns and they're coming from the same arithmetic series, I know that the a and d are the same. So I should be able to solve with two equations and two unknowns. I should be able to find them. If I want two of the same unknowns, should I be using this first formula or the second one? Why the second one, Kylie's? Yeah, so if I'm trying to solve for a and d, I would like my two equations to actually have a and d. This one has a tn, it doesn't have a d. So I'm going to use the second equation here. So we're going to set this up for what we know. And we're going to do 710, or I guess I'll show sum of 20 first. So we know the sum of the 20 terms. So I'm plugging in 20 for all of my n's here. And I know the sum of the 20 terms is 710. So I'm going to do 20 divided by 2 is 10 here. And then 2a plus 19d. All right, so we've got these two equations with two unknowns. There's a couple ways that we can go about solving this. If I have two equations and two unknowns, I can use elimination where I stack them, but I have to get rid of this guy first because I can't have a multiple out front like that. I need them to be like individual and movable terms. Or I can isolate for one variable in one equation and sub it into the other. That's substitution, right? A good thing just to do, just to simplify our lives a little bit, could we divide out this 10 and just kind of get rid of that on both sides? Let's do that quickly. Just make our lives a bit easier. Perfect. Okay, now our job is to either use substitution or elimination. It does not matter which one you use. Bonnie, do you want to choose a method for me? Sure, elimination. So the only thing about elimination is that if I'm eliminating, I need the A's to have the same coefficient or the D's to have the same coefficient, which I don't have right now. How could I make that happen? We could, yep. But in the case that you want to use elimination, how do we make sure that our A's and D's have the same coefficient? I can divide 2, but then I'm going to have bad fractions, which I don't want. What would be the opposite of that? Yeah, could I do like this whole thing times 2, and then we'll just write it over here, each term. So we'll have 68 equals. You can do either method, it's okay. Both work fine. And then now I'll be able to eliminate my A's because they have the same coefficient. If they don't, I'll have A's still left over once I subtract them. Oh yes, thank you. Good catch. Okay, so we're going to get 3 equals, that's 0. And then we actually only have one D here, so that one's really easy to, we don't have any more calculations from there. So we're just going to find our A value, and we're almost there. By subbing that back in, I'm just going to sub it into the one before we multiplied by 2, because those are equivalent equations anyways. And then I'll just do 34 minus 27 to get my A value. Okay, what was the goal of the question again? What's it asking us to do?
Some of the first 20 terms. Oh no, 25th term.
Determine the 25th term. So should I use the sum formula or the sequence formula? Sequence, yes. We don't want the sum of the first 25 terms, we just want to know term 25. So I'm going to plug term 25 into our sequence formula with the A and D that we just found, and then we'll just calculate it. Okay, so I'm getting 79. Someone just want to check that out for me, make sure I did it right.
Yes.
Great. Okay, if I had used substitution, just so we know, I would have isolated, you don't have to write this, I would have isolated for A by moving the 9D over, and then I would have replaced this A in that sum formula with 34 minus 9D, and then just solved for D. So it probably would have taken me about the same amount of time as elimination did. Questions on this guy? No? Do we need a little break before we finish the last two? Okay, 2 minutes, we'll pause it. Okay. All right, determine the sum of the first 7 terms of the geometric series in which term 5 is 5 and term 8 is negative 40. Okay, SA, can you take out your headphone, please? Thank you. So I could solve this a couple of ways. If I want, I could make 2 equations and use substitution and all that kind of stuff, but I did teach you a quick little way that you can figure out the R value if I know 2 random terms in the sequence. Does anyone remember how we do that? Avery, can you like turn around and... I know Nicole and Marianne are awesome, but I'm awesome too, okay? So... that's D. You're thinking D. So there's a quick little way that I told you guys how you can find the R value in a series, in a geometric sequence, if you're given 2 terms. Division. So I will take the term that is further along in the sequence, and I will divide it by the term that's earlier in the sequence, which is 5. And then how do I do the difference of these 2 guys? What do I use that for?
Difference means subtract.
Well, yes, I will subtract them, which will give me 3, but how do I use that in this calculation? Root. So here we will actually do the cube root of this, which will actually give us the cube root of negative 8, which tells us that our R value is negative 2. Okay, so guys, what we're doing here, why the math works, is because I'm finding the multiple difference between negative 40 and 5. So I'm dividing that into what we multiply 5 by to get negative 40, which gives me negative 8. And I want to split that into equal multiples so that I'm doing a constant multiple to get from term 5 to term 8. So if I want to split 8 into 3 equal multiples, I'm going to cube root it. And then I'm saying essentially that I'm multiplying 5 by negative 2 3 times to get to term 8, which is negative 40. Does that make sense? Okay. If you really want, another way that you could have done this is guess and check. So I have 2 terms between 5 and negative 40. How do I get there? Fill in the blanks. Or I also showed you guys how we can set up the formulas and use substitution and find R from there. Okay? I still need to find A. So if I'm finding A, I need to use one of these 2 pieces of information. Or I can also just go backwards with the sequence if I want, but I think I'll just use like a little formula here. This is our formula for a geometric sequence. So I'm using, again, the sequence formula to help me before I do the sum. And I know term 5 is 5. I don't know what A is, but I do know that R is negative 2. Whoop, sorry. Don't worry, it's still here. And this gives me negative 16. And then I can just divide that out. The nice thing about using the formula in this method is that it's easier for me to leave this in exact values than if I were trying to just figure this out by writing out the sequence. That might be a little bit more challenging.
Wait, doesn't it go over R minus 1?
No, we're not doing the sum yet. This is the sequence, so I'm using the sequence formula to help me find A. So I need A and R to find the sum. Yeah, so we're going to leave in exact values though, so that when we do the sum, we'll also leave that in exact values. Yeah. Emmanuel?
So when you're solving for R, is it
Yep.
3 outside of the root because you're just subtracting 5 from A?
Yes. Yeah, it's the difference between the terms that you have. Yep. Okay, now I want to find the sum of the 7 terms, and I'm going to use that geometric formula where we do this. And I'm going to plug in what I know. So I know, and again, we're working on leaving things in exact values in this course, so I'm going to do the same thing here. Make sure your negative 2 is put in brackets, especially when you're raising it to an exponent. We want to make sure that the negative is calculated properly. And then we're just going to work on simplifying this and leaving it in exact form. So I'll do negative 2 to the exponent 7 first. Because I'm doing a negative to an odd exponent, I will get a negative back out from that. So it'll be 128 minus 1, and all of this will be divided by 3. Okay, if you want, you can think about this as negative 129 over 1, because we're going to actually multiply those two guys together. So long as 16 doesn't go into that value, which I highly doubt. Or we can double check that. Okay, and then I'm going to do negative 5 times negative 129, which gives me positive 645 over 16. And I want you guys to think of this bottom part as if it's also over 1, because what we're going to do next is when we divide a fraction by a fraction. Avery, what do we do? I feel that you want to answer this question. What do I do when I'm dividing a fraction by a fraction? What's the rule?
You multiply by the reciprocal.
Yeah, flip and multiply. Perfect. So smart. Okay, and then I think we can cross cancel here because or maybe 3 goes in here. Yeah, it does. So 3 goes in here 215 times. And then we've just got 215 over, oh, and negative, don't forget the negative, over 16. Beauty. You need some practice with your algebra?
Yeah. Serious practice.
All right, questions for this guy? Most of it was just like the math part of like simplifying. But is there anything else that anyone is curious about? Any steps that I did? We're good? Okay, last question of the day. We are going to calculate the sum of this geometric series. Problem being is that I don't know how many terms are in here to find the sum. So, suggestions for how we can do this question. What should we do? Why don't we start by writing down?
Equals
Okay.
960.
Natalie was very excited about that. Bonnie?
D is half.
R? You mean? Yeah. R is half, that's right. I don't know the number of terms in the sequence, that's kind of a problem, but I do know the last term in the sequence is 15. And in order to find the sum, I'm going to need to know how many terms are in here. So
Why does T n equal 15?
some term that's at the end of the sequence equals 15, right? So the last term, yeah. But I don't know what term that is. So suggestions? If I'm,
We can isolate n
okay, from what?
from the geometric formula. Sequence formula.
Good. Geometric sequence formula. Okay, I mean, do we need a formula for this? We could write out the sequence. I mean, we're halving this anyways. It's gonna be like pretty quick by the time we get to 15, right? So one option is, if you want, you can plug in A and R, and you can plug in 15 here, and you can try to find the n that makes that true. We did an example of that yesterday. Sorry, 2 days ago, I think. So I can totally do that. Or if I know that we're at 960 plus 480 plus 240, what's the next thing in my sequence here?
120.
Okay, and then?
60.
Mm-hmm.
30.
And look how fast that was. So how many terms do we have?
7.
I have 7. Do I need a formula for the sum? Could I just add these together in my calculator? We have 7 terms. I mean, that's pretty easy, right? So let's just add them together. We'll find the sum of the 7 terms. What'd you get? 1,905. 1,905. Anyone else? Let's just double check that. Joey, what'd you get?
1 out of 5.
Oh yeah? Anyone else get that?
Yeah.
Okay. Beauty. Okay, so again, this is the case where it's more efficient for us just to write out this series than it is to use the formulas. So it's okay to do that. All right.